And we're back again for another part of this Parallax NPM library series. And in this part, we're going to look at testing our library using a tool called Jest. So if you've stumbled upon this video trying to learn about testing, you're probably going to learn a thing or two. But if you're interested, this is part of a whole series, so you can go back to part 1 and learn all about the library that we've built to help people build Parallax websites that we're ultimately going to deploy onto NPM. So back to this video. So we're going to write some tests using Jest. Jest is a testing tool that was made famous in the React world, but it's become a pretty well-respected testing tool for JavaScript in general. First things first, we're going to need to install Jest. So I'll just paste in the command here. So we're going to yarn add dev dependency. We're going to add Jest, Babel core. We already have this, but we're just adding it there just to be sure that we have it. Babel Jest, which allows Jest and Babel to work nicely together, so we can use modern JavaScript syntax in our tests as well. And then Babel-core @7 bridge. And the reason we need that is because we're using the new version of Babel, Babel 7, but Jest needs a sort of a bridging tool between the old version and the new version. And that's what this bridge does. So with all of that, we'll run that and I will see you when it's done. So there we go, we've got all of that installed. So the next thing, I'll just add a couple NPM scripts to allow us to run our tests. So I'll open up the package.json and I'll paste in 2 more scripts here. So we have the script called test, which simply runs Jest, and test:watch, which runs Jest on all of the source files, watching them, and --notify, which will actually send us a system notification every time Jest tests run, and it will tell us how many are failing, how many are passing, etc. And one other thing you could do, if we come back into the terminal, is run jest --init, and that didn't work, so npx jest --init. So the reason this didn't work is I don't have Jest installed globally on this system. So if we use the command npx, which comes bundled with npm, it allows us to use the binary that's in the node modules of the current directory. So if we run this, it will allow us to run that command. So I'll just say we're going to run it in JS-DOM. Would we like coverage reports? Yes. Automatically clear mocks? Yes. And there we go. And that's created this jest.config.js. This isn't completely mandatory, but it is something that you can do if you wish. And with that, we have enough to start writing some tests. So I'll make a new directory, I'll call it test, and inside it I'll write test.spec.js. We'll open that up, and we need to import in the Parallax library. Import Parallax provider from source. And now we have that, we can start creating some tests against it. But we need to think about how we're going to test this library, because this library relies on scrolling events. So the user manually scrolling through a page, and that's going to fire off events that are going to trigger different functionality. But nobody's going to be scrolling because we're in this automatic test environment with Jest. So we're going to need to be able to mock scrolling events. So the way we'll do that is using the Jest global object. And because we're inside JS-DOM, that global object will be equivalent to the window object in the browser. When our library calls add_event_listener on the window, Jest will know to access methods in the global object. So then we can set a method on the global object called add_event_listener, and that will allow us to create the functionality that we want, and then ultimately trigger the scroll event when we need to. And we want to mock that before every test runs. So we'll use something in Jest called before each. So before each, and then that accepts a function, and then in here we can have some code that will be run before every test in our test suite. So I'll create a global events map like so, and I'll just set that to an empty object at the start of this code. And then I can call global.addEventListener equals, and then here I'm going to use something called Jest.Function, and then pass that an actual function of my own. So what Jest.Function is something that we can use in place of a normal function, but it will allow us to then make assertions against that function. Like for example, we could ask Jest, has that function been called? How many times has it been called? What arguments was it given when it was called? And these sorts of things like that. And then we can make assertions against those to make sure that everything is working as we expect. So here, we're setting the addEventListener to be one of these Jest functions, and then the function that we pass Jest function is what will actually run when this method is called. So, of course, we want to simulate or mock the addEventListener. So the first thing that gets passed into addEventListener is a string, which is the event to be called, and then a callback. So then in the events map, I can say events event. So in this case, when it's called with the scroll event, then the scroll key in that events map will then equal that callback. So now in our tests, we could actually do this and say events.scroll. Like that. And events.scroll is the scroll key in this events object, and that is this callback. So we can call it there, and that would just be like simulating the event being triggered by the browser. Because when a scroll event is triggered by the browser calls the callback that you've given it. So by us storing that callback and then calling it like this, we're simulating the way the browser would call that callback on a scroll event. So we'll clean that up and we'll start writing some tests. So we'll create a describe block, and a describe block is just a way of grouping tests, and we'll call this scroll event, and then that takes a function. And here we'll need a bit more setup for each of the tests. So we'll create another before each block. And keep in mind that these before eaches are scoped. So this before each will run before every test in this file because it's global to the whole file. But then this before each will only trigger before every test within this describe block. So then inside here, we're going to want to create an instance of our Parallax provider. So we'll say const p equals new Parallax provider, and then we'll give that an array as it expects, and we'll just fill this out. And I'm actually going to make this duration a variable that exists globally within this describe block. So I'll call it section1 duration. And then up here, I'll call section1 duration equals 500. And I'll do section2 duration equals 800. I'll create controller, and the controller I'll create as another Jest function. So I'll call this section1 controller, and I'll define that up here too. Section1 controller equals Jest.Function. And I'll say section2 controller equals Jest.Function. And I'll create another section, mount point 0, duration, section2 duration, controller, section2 controller. So now we've got a basic instance of our Parallax provider with two sections, and that will be created brand new before every single test that we define. So speaking of those tests, let's define some. So let's write the first test, and I'll say calls the add event listener for the scroll event. So that is the first thing that we are going to test, and we'll expect, so this is a function that Jest provides us where we can expect something and then we can chain on expectations. So in this case, we're expecting global.addEventListener, which remember we defined up here. Global.addEventListener is this Jest function. Expect that to have been called with. So now we're going to assert that it's been called with certain arguments. And the first argument we expect is the string scroll. And the second argument we expect to be a function. So we can just say that we expect any function. If I could spell. And that is our first simple test with Jest. So we're just expecting that this global add event listener, which is a Jest function, has been called with the argument scroll and the second argument just any function. So now I'll close out of Vim and I'll run yarn test. And then
hello darkness, my old friend. I've come to talk with you again.
And our test fails. Expected mock function to being called with scroll and any function, but it was not called. Interesting. My inkling is, so I called document.addEventListener here, but we set the global addEventListener in Jest, which is equivalent to the window object in the browser, but we're calling addEventListener on the document here. So if we go back into our test, up here, we can say global.document.addEventListener, and of course we've changed that value, so we need to change our assertion to be global.document.addEventListener, and we'll close out and run yarn test again, and we have a passing test. This has unintentionally illustrated a good point in testing, which is we should always start with failing tests and then change things so that they're passing. Because if you start with passing tests, they might be passing for a reason that isn't what you think it is. So it's much better to start with an intentionally failing test and then change things to make it pass, because then you can be sure that when it's passing because of the change you made. And then you can be more sure that your tests are correct. Unintentional caveat, but that is a good point. So we will open Tmux now so that we can have multiple windows, so that we can run yarn test watch here, and then we'll just click A to run all tests, and then that is running all of our tests. We'll come back into Vim and just minimize out that test runner, but it is running there in the background. So now we can just create some more tests. Give myself some more room. So test. It should call the controller. So here we're just going to assert that the controller should be called when a scroll event happens. So we'll call events.scroll. Just like we discussed before, that simulates a scroll event in the browser. And then once that's finished, we expect section1 controller, which is being defined up here as a Jest function, and it's global to this describe block, so we have access to it in our tests, and we expect that to have been called. So we're not going to assert what arguments it's been called with or how many times it's been called. We just want to know that it has been called. So now if we come into our tests, we have 2 tests passing. We get a nice little check mark next to each with the name of each test. So I just want to retouch on the start with failing tests idea. So right now we wrote this test and it's immediately passing, but we want to verify that it will actually fail if we break something. So let's comment out this events.scroll so the scroll event won't be triggered. So in that case, our assertion is wrong because we expect that it hasn't been called, because if it has been called, something's wrong. It shouldn't be called because the scroll event was never called. So we'll save there, and there we go. We have 1 failing test. And if we just maximize this, scroll events, it should have called the controller, expect that the Jest function to be called, expected the mock function to have been called, but it was not called. And that's good. That means that everything is working as we expect. We uncomment it, resave, and we have a passing test. So another thing to consider in our next test is that when we call that scroll event, we're also looking at the global offset of the scroll, the page Y offset. So we're going to need to set that in Jest using that global object so that our library can hook into it, and then we can make assertions about what the relative offsets that each controller should be receiving is. So let's do that. Test correct offset when inside the section. So here we'll set global.pageyOffset, and we'll set that to 10. And then we'll trigger the scroll event. And then we can say expect section 1 controller to have been called with, and we want it to be called with global.pageyOffset, because this is the first section, so its offset is the same as the global offset because the first section is mounted at the very top of the page. And the second argument should be section 1 duration. And again, jogging your memory, section 1 duration is defined up here in the top of the describe block. So again, we come into our tests, we have 3 tests passing. But if we add 1 onto that section duration, for example, expected mock function to be called with 501, but was actually called with 500. So everything is as we expect again. So I'm just going to copy this test and change the page Y offset to be much larger so that we're actually after the section to make sure that the code still works. So we'll change this to after the section, and we'll set this to like, say 10,000. And again, we can come down here and see 4 tests are passing. Good. So these are the easy case with the first section, but now let's write a few tests to check the second section's values are correct, where we actually have to do some trickery with the relative offset. We'll do correct offset before section 2. Again, global.pageyOffset, and we'll just set it to 10 again. Events.scroll, and then expect section 2 controller to have been called with, and this time it should be called with global.pageyOffset minus section 1 duration. And the second argument should be section 2 duration. And come down, and we have 5 passing tests, so we'll just keep going. Correct offset inside section 2. And we'll copy that code. And we'll set this to a value that's inside section 2. And again, the rest of this test is still the same. So we can save, and we have 6 passing tests. Good. Chug along. Correct offset after section 2. And we will again copy this, paste it in there, and change this to a large value. Save it. And we have 7 passing tests. And you might be thinking that this is kind of redundant, just basically copy pasting these 3 tests and just changing the Y offset. And you might be right, but I just personally like to have tests that cover all logical usages of whatever you're testing. And in this case, logically, the way that I think about this library, each section can be triggered before, during, or after. And maybe in the future, certain functionality gets added that does some fancy trickery in one of those areas. And if it does, it might break in that and not in the others. And if that happens, and we're not covering all of those use cases in our tests, our test suite might continue to be 100% passing, but we've actually broken something. But by having this little bit of redundancy, I just feel a bit more confident that my tests are going to catch subtle bugs if I ever introduce them. And ultimately, that's why we test in the first place. We want to try and catch these subtle regressions and bugs that we can introduce when we add things or manipulate things in our code base. It's up to you whether you want to add in this redundancy, but I'm just showing you what I like to do, and it's not really that much extra work to get it done anyway. So I think the extra work to the benefit you get for that little bit of extra work is well worth it. So at this point, we've got a pretty decent test suite. We've got tests that cover all major usages of the library. We know that the library is working for passing the correct offsets and durations, and we know that it's calling the correct controllers. We know that it's calling the event listeners that it's supposed to. So the only one thing that I feel like we haven't tested right now for our current library and the current functionality is, can it handle negative mount points? Because obviously the mount points now are relative to the previous section. And in the example that we built, we used a negative mount point at one point. So we need to make sure that our library handles that negative mount point correctly. So of course we can't use this describe block, because this describe block sets up the provider with mount points of 0. So we're going outside of the describe block, and we'll write one more test, which will just be global, and we'll say it should handle negative mount points. And fix that. So here we're going to want to create a new instance of our library and give it a negative mount point for one of the sections. So we'll just say let section controller equals jest.function. Let section duration equals 800, and let section mount point equal minus 500. And then we'll just say const p equals new parallax provider mount points 0. So this is the first section we don't care about. It's the second section that we're going to mount with a negative mount point. Duration 500 controller, and we'll just give it an empty function. And then mount point equals section mount point duration equals section duration. Controller is section CTRL. And with that done, we will set the page Y offset to be, say, 850. We'll call events.scroll. And then we'll say expect section controller to have been called with. And then we're going to need to calculate the offset it should have been called with. So section 2 was mounted negative 500 pixels before the end of section 1. And section 1's duration is 500. So effectively, section 2 was mounted at point 0. So it should be called with the offset of global.pagey_offset. And of course, section duration is the duration it should have been given. So if we take a look, we have 8 passing tests. And just to be sure, we will comment out that scroll, and we now have a failing test because the controller was not called, which is what we expect. Now we'll go back to 8 passing tests. So I think we've rounded up testing this library pretty well. And you've had a good introduction to what Jest is and what Jest is capable of. And I hope that that's introduced you to what testing really means, because testing is often not covered in programming tutorials on the internet. But if you're going to work professionally, you're going to have to know how to test software, because you're shipping code potentially to millions of people, and you want to be as confident as possible that your code doesn't have bugs in it. And of course, testing does not mean you will never have bugs in your code. You will. You will always have bugs in your code. You might even have bugs in your tests. I mean, it's just like inevitable that that's going to happen sometimes. But ultimately, having tests allows you to be more confident in the software that you're shipping. because you know your tests are passing, and then you make a change, and your tests are still passing. So that means you haven't introduced an obvious egregious bug. And you'll be surprised by how often you actually do introduce bugs doing that, and you catch them because your tests start failing. And then you're like, oh, I changed that, and you realize what the bug is, you fix it, and it's like, happy days, I'm not shipping broken software. But if you didn't have those tests, you would write the code, and the thing that you were supposed to write is working perfectly, but you've broken some other random part of your code, and then your tests are failing, or your tests, if you had them, would be failing, but you never noticed because you didn't have the tests. You ship the code, and then suddenly you have angry customers saying, oh, the code's broken. And then you're kind of like up at 3 a.m. trying to fix a bug that if you had just spent 10 minutes extra writing some tests, you wouldn't have had to do. So definitely something to think about. But yeah, so anyway, enough of that rant. So in the next part, we will be deploying this library onto NPM, and I'll explain some best practices around open source software and ensuring collaborators have a consistent code style using linting like ESLint and formatting like Prettier and Git hooked with Husky and lint staged, and we'll use Travis continuous integration and deployment. It's just a whole action-packed video coming up. So I'll see you in that next video. But if you like this video, give me a big thumbs up, subscribe button, bell notification, all of that good stuff. But until next time, stay hungry and keep coding.